Okay, so finally I want to just kind of extend out and talk a little bit more about each of these questions. And we're asked to state whether the function below would be used, that would be modeling this scenario, would be linear or nonlinear. So here we have water dropping from a leaking tap are falling into a bucket at a constant rate. So constant is important. But here we're modeling the volume of the water versus time passing. So as time passes, we're looking at how much water is going to be in the bucket. So if it's increasing at a constant rate, that means if it starts at no water in the bucket, and then every hour it's increasing a centimeter, or a volume of volume would be a liter. So it would be like 1 milliliter of water for the first hour, and then it increases another one, so it becomes 2 milliliters after 2 hours. So it's going to be increasing by a constant rate. So yes, this would be considered linear. Okay, now snowball rolling down a mountain doubles its volume every 5 seconds. It has to model the volume, and we are looking for a scenario that models the volume of the snowball as time passes. So again, we're looking for that volume of the snowball. But the key word on this one is that it doubles. Doubles don't increase at a constant rate, because if we think about, okay, we started at 1 milliliter, or 1 whatever volume unit you're using, and you double that, you get 2, and then I double that and I get 4, and then I double that and I get 8. So I'm increasing by 1 here, I'm increasing by 2 here, and I'm increasing by 4 here. So I'm not increasing by the same amount each time. So this is not linear. Okay. Now, this last one is a raindrop falling from the sky, and it speeds up by 9.8 millimeters per second every second as it's pulled down by gravity. So it's a constant rate that's increasing by. But the model is not modeling, we're not modeling the speed that it is. We're modeling the distance that it's been traveled by the raindrop as time passes. So it's not 9.8 and then increasing another 9.8. It's not the speed that we're modeling, it's the distance traveled. And so because of that, this is actually a non-linear. This is going to be considered a non-linear function. All right, now the last couple statements, just asking if they're true or false. So every arithmetic sequence can be modeled by a linear function. So this is most definitely true, and it is a true statement because linear and arithmetic both have a constant rate of change, and that's what makes them what they are. The arithmetic sequence has that common difference, that exact amount that's going to be increased each time, whereas linear function also has the constant rate of change. So it's going to be true. Here, we can find different rates of change in an arithmetic sequence using different pairs of terms. That's going to be false, because no matter what pairs of terms you use, you always have the same. It's a constant rate of change. Okay, so it's always going to have the same rate, and that's what makes this a false statement, is that it needs to be, you're going to always have a constant rate of change no matter what pairs of terms that you use. And then finally, an explicit equation is a linear function. That is true when we are talking about an explicit equation for an arithmetic sequence, because once it's been simplified, it takes the form of that linear function. And so that is a true statement. Okay. So if you have any questions on any of your notes or anything like that, please make sure you come and talk to me. There's a lot of information here, and we're going to be continuing with a lot of practice problems and things along those lines. So I'll be happy to help you with anything that you need to. Just ask.